Space is not the silent void we once imagined. Hidden within the swirling clouds of interstellar plasma, astronomers have intercepted 25 mysterious signals that defy all explanation. By the end of this journey, you will know the most perplexing cosmic enigmas challenging our understanding of the universe. We will explore signals that repeat with impossible precision and others that whisper in harmonic cascades. What does it mean when a nebula broadcasts a pattern that mirrors a fundamental mathematical constant? Are we listening to the natural songs of chaotic plasma, or could we be hearing something else entirely? What do you believe is waiting for us in the cosmic static? Deep within the luminous heart of the Orion Nebula, the first of our 25 mysteries begins not with a shout but with a whisper. This is the whispering giant, a signal so profound it was almost missed entirely. Unlike the violent crackles and pops we normally associate with interstellar plasma, this emission is a steady, low-frequency hum, a constant drone that seems to permeate the very fabric of the nebula itself. It is a sound you could almost feel more than hear, a cosmic vibration. What makes it so strange is its modulation. The hum is not a pure, simple tone. Instead, its intensity rises and falls in a gentle, rhythmic pattern, like the slow, deep breathing of some colossal entity. Our current models of plasma physics cannot account for this behavior. Turbulent clouds of ionized gas produce chaotic bursts of energy, not this serene, structured pulse. It suggests a level of organization within the chaos that we simply do not comprehend. Is this the signature of a natural process we have yet to discover, a fundamental resonance of space itself being amplified by the nebula's unique structure? Or does the sustained, almost deliberate nature of this hum point toward something else, something that is using the plasma cloud as a medium, a cosmic loudspeaker for a message we are only just learning how to hear? It is a rhythm that should not exist. Far from the gentle hum of Orion, a second signal carves its name into the void with the sharp, unwavering beat of a cosmic metronome. Emanating from a violently turbulent plasma region within the Cygnus Arm, this repeating pulse arrives with a precision that defies the chaos of its birthplace. The interval between each burst is not merely consistent, it is mathematically perfect, ticking away with a regularity that mirrors the most accurate clocks ever built by humanity. How can such order emerge from a stellar environment defined by its disorder, where superheated gases collide and magnetic fields twist into knots? One compelling theory points toward the interactions of dense, spinning neutron stars. As these stellar corpses rotate, their powerful magnetic fields can funnel energy into tight beams, sweeping across space like a lighthouse. If one of those beams were to sweep past Earth, we would perceive it as a regular pulse. Yet even this elegant explanation falters. The environment surrounding a neutron star is a maelstrom of its own making, a place where such perfect timing is often subtly disturbed by infalling matter and gravitational waves. This pulse is too clean, too immune to the tempest around it. This impervious regularity forces us to consider far more speculative ideas. Could we be detecting a structured pattern deliberately hidden within the natural roar of stellar winds, a signal designed to be found by those who know how to listen for order within the chaos? Is the universe itself a clockmaker, or are we hearing the faint, rhythmic ticking of something that knows we are here? The metronome's perfect rhythm gives way to a symphony. Drifting from the vast Carina Nebula complex, the third signal is not a single tone but a cascade of them, a waterfall of harmonically related frequencies that flow into one another like a chord progression played on a cosmic scale. It begins with a deep, resonant fundamental frequency, and from this bedrock higher notes emerge, each one a perfect multiple of the first, creating a shimmering, layered sound that is both beautiful and profoundly unnatural. This is not the random noise of superheated gas. Simple plasma oscillations might produce a dominant frequency, but they do not spontaneously generate this intricate, layered harmony. It is the difference between a single struck drum and an entire orchestra performing in perfect, ghostly synchrony. The existence of such a harmonic cascade implies a level of energy transfer and resonance within the plasma cloud that our physics cannot yet map. It suggests a system where energy is not just chaotically dissipating but is being shaped, filtered, and orchestrated by forces we have not yet identified. Could immense, unseen magnetic fields be acting as a natural soundboard, sculpting the raw noise of the nebula into this complex chord? Or does this intricate structure hint at a process far more dynamic, a kind of self-organization within the cloud where the plasma itself begins to sing in concert? The universe has composed a piece of music, and we are left to wonder what kind of instrument could possibly be playing it. From the nebula's symphony, we now turn to a ghost. In the aftermath of a star's violent death, within the expanding shell of the Vela supernova remnant, a fourth signal haunts the debris. It is known as the ghost echo. The initial burst of energy is typical, a sharp crack of radio waves from the turbulent plasma. But then something impossible happens. Moments later, a second, fainter pulse arrives. It is an almost perfect replica of the first, a spectral duplicate that should not exist. In the chaotic environment of a supernova remnant, signals do not echo. The energy is either absorbed by the diffuse gas or it travels onward into the void, never to return. This is not a simple reflection. The echo is too clean, too precise in its replication of the original burst's complex structure. So where is it coming from? One theory suggests the initial blast wave might have encountered an incredibly dense, unseen structure on the far side of the remnant, a wall of cold gas or a dark, rogue planetesimal. The energy could have bounced off this object and been flung back toward us, creating the delayed echo. Yet the odds of such a perfect alignment are astronomically low. Another, more profound possibility is that we are witnessing a completely new form of plasma wave interaction. The supernova's blast might have excited the local interstellar medium in a way that creates a kind of resonant cavity, a region of space that briefly traps and then re-emits the energy, like a whisper bouncing between two canyon walls. If this is true, it means our understanding of how energy propagates through the universe's most common material is fundamentally incomplete. Is the ghost echo merely a cosmic coincidence, a trick of geometry, or is it the signature of a physical law we have yet to write down? The ghostly echo fades, leaving us with a phantom of a signal, but our next discovery offers something far more concrete. Near the vast, luminous arc of Barnard's Loop, a fifth signal was intercepted that refused to be categorized as mere noise. When astronomers processed its raw radio waves, they did not hear a tone or a pulse. Instead, they found a data burst anomaly, a rapid-fire transmission of seemingly encoded information. The signal itself is a torrent of distinct, discrete packets, each one a short burst of energy. At first glance, it could be dismissed as the chaotic sputtering of magneto-hydrodynamic turbulence, the complex churning of plasma under the influence of powerful magnetic fields. Such natural processes can create intricate patterns like the swirling eddies in a fast-moving stream. But this is different. When researchers analyzed the intervals between these bursts and their varying intensities, they found a distinct, non-random structure. The pattern does not conform to any known natural sequence. It lacks the predictable repetition of a pulsar, yet it also avoids the total chaos of pure turbulence. It sits in a troubling middle ground, exhibiting a statistical signature that, in human terms, we would associate with a primitive form of information encoding. Think of it like listening to the static on a radio. Most of it is random hiss, but then you hear a brief sequence of clicks and pauses that almost sounds like a coded message in Morse code. Your brain instinctively tries to find meaning in it, even if it is just noise. That is the exact dilemma facing scientists. One camp argues this is precisely what is happening, a case of apophenia on a cosmic scale, where we are seeing patterns in the complex but ultimately natural dance of superheated gas. They point to sophisticated computer models that can simulate similar data bursts from pure plasma physics. The other camp, however, remains unsettled. They counter that the specific structure of these packets, with its low level of entropy and its peculiar symbol distribution, is statistically anomalous. It resembles a rudimentary language or a simple counting system more than it does any known stellar process. So, are we witnessing the birth of a new branch of astrophysics, where plasma can spontaneously generate complex, information-like structures through processes we do not yet understand? Or does this data burst represent our first tentative reception of a cosmic broadcast, a message not of words or music but of pure, fundamental pattern? The silence from Barnard's loop is now filled with a profound and troubling question. While the data burst presented a puzzle of pattern, the sixth signal presents a mystery of pure endurance. Designated the solitary long-duration wave, this emission was not a brief crackle or a repeating pulse, but a single, continuous waveform that persisted for an astonishing 48 hours. It simply hung in space, a steady broadcast from the heart of a remote plasma cloud in the Ophiuchus constellation, outshining the background static with its unwavering presence. Such longevity defies all conventional explanations. Known cosmic events are either incredibly brief or they evolve. A supernova's initial flash is over in moments, and while its remnant glows for millennia, that light changes and fades. Even the most powerful plasma instabilities, vast magnetic reconnections that can release staggering amounts of energy, are transient events flickering out in minutes or hours at most. This signal did not flicker, it did not fade. It simply was for 2 full Earth days a solitary note held against the cosmic silence. What kind of process could possibly fuel such a sustained, unwavering output? One school of thought suggests we witnessed the slow, agonizing death of an exotic object, like a star being torn apart over an immense timescale by a supermassive black hole. Yet no accompanying gravitational waves or X-ray emissions were detected that would support such a cataclysmic scenario. Another, more unsettling idea is that the source is not a single event at all, but a persistent engine. Could there be a stable, localized phenomenon within the plasma cloud itself, a self-sustaining reaction that somehow feeds off the cloud's own turbulent energy, focusing it into a coherent beam that lasts for days? This would be like finding a single candle burning steadily in the heart of a hurricane, completely untouched by the chaos that surrounds it. The solitary long-duration wave challenges our most basic assumptions about how energy behaves in the cosmos. It asks us whether the universe harbors processes that are not just powerful but profoundly, impossibly patient. If patience defines the last signal, the seventh is defined by a profound and deliberate change. Drifting from the dense, dark heart of the Rho Ophiuchi cloud, this signal presents a frequency-drifting enigma. It does not hold a steady note like the solitary wave, nor does it repeat with mechanical precision. Instead, its frequency slowly, inexorably glides over time, sliding up or down the radio spectrum in a smooth, continuous sweep. At first, this seems to have a simple explanation: the Doppler shift. We hear this effect every day. A siren from a passing ambulance rises in pitch as it approaches and falls as it moves away. In space, a star or a planet moving towards us would compress its radio waves, shifting them to a higher frequency, while one moving away would stretch them, creating a lower pitch. The problem is the drift from the Ophiuchi cloud does not match the clean, predictable curve of a single object in motion. The change is too linear, too controlled, as if the source itself is not moving through space, but is instead transforming from within. This points directly to the signal's origin within the cloud's own plasma environment. Could the drift be caused by the emission source itself undergoing a radical physical change? Imagine a vast, vibrating structure deep within the cloud, a natural radio transmitter that is slowly collapsing under its own gravity or perhaps expanding as it heats up. As its physical dimensions alter, the frequency at which it naturally resonates would also change, creating the steady glide we detect. Another possibility is that we are not hearing a single object, but a wave propagating through a medium of shifting density. Think of how light bends when it passes through a glass of water. If this radio signal is moving through layers of plasma that are themselves in motion, with densities and magnetic fields that vary, its path could be subtly warped, creating the illusion of a drifting source. This enigma forces us to ask what kind of natural process can orchestrate such a smooth, controlled transformation. Is the Rho-Ophiuchi cloud hiding a cosmic engine that is methodically tuning itself? And if so, what could possibly be turning the dial? This drifting signal presents a mystery of transformation, but our eighth discovery is one of pure, unwavering alignment. From the cold, dark depths of the Taurus molecular cloud, a beacon cuts through the cosmic noise with a startling property. Its radio waves are not chaotic and scattered. They are highly polarized, meaning they oscillate on a single, preferred plane, like light passing through a specialized filter. Such a coherent, organized signal is extraordinarily rare for emissions born from the turbulent soup of a plasma cloud. Normally, the frantic motion of charged particles in a plasma scrambles any inherent alignment, producing a jumble of waves vibrating in all directions. The existence of this polarized beacon implies something is imposing order on that chaos, funneling the energy into a single, clean vibration. The most likely architect is an immensely powerful and structured magnetic field. Imagine the plasma cloud threaded by invisible lines of magnetic force, so strong and orderly that they force the escaping radio waves to dance in perfect unison. This points toward a hidden source within the cloud, a celestial object with a magnetic field of unimaginable intensity. We are likely detecting the ghostly influence of a protostar, a star in its earliest stages of formation, whose powerful magnetic fields are channeling material onto its surface and, in the process, acting as a natural radio laser. Or perhaps it is the signature of a neutron star, a stellar corpse whose magnetic field is 1 trillion times stronger than Earth's, whipping the surrounding plasma into a frenzy of ordered emission. Yet the purity of this polarization gives some researchers pause. It is so clean, so perfect, that it pushes the boundaries of what we believe even these extreme objects can produce. Could we be seeing the signature of something even more exotic, a theoretical object like a magnetar, whose magnetic fields are so intense they can twist the fabric of spacetime itself? The polarized beacon does not just offer a signal, it points a direct finger at the hidden magnetic architecture of the cosmos, challenging us to find the object powerful enough to build such an orderly lighthouse in the dark. The magnetic order of the polarized beacon is shattered by our ninth signal, a blast of pure, unadulterated power. From the vibrant stellar nursery of the Lagoon Nebula, an ultra-high-energy spike erupted, a flash so intense it momentarily blinded our most sensitive radio telescopes. This was not a sustained note or a drifting frequency, but a singular, explosive event over in a fraction of a second. The detectors did not just register it, they were saturated, overwhelmed by a torrent of energy that pushed their limits. In that fleeting moment, it was as if a cosmic flashbulb had gone off, pointed directly at Earth. The immediate question for scientists was a critical one. Did this come from the depths of space, or was it a ghost in our own machine? The first and most skeptical explanation is an instrumental artifact. Our technology is complex, and a random glitch, a surge of power, or even a stray particle striking the detector itself can create a false signal. Researchers meticulously checked the logs, searching for any sign of a local malfunction. They found nothing out of the ordinary. The next possibility is a cosmic ray impact. These are subatomic particles, often protons, traveling at nearly the speed of light. When one slams into our atmosphere or even directly into a spacecraft, it can create a brief, powerful burst of radio noise. Yet, the specific signature of this spike, its unique spectral fingerprint, did not perfectly match the profile of a typical cosmic ray event. It bore the hallmarks of an emission that originated from within the nebula's own plasma. If this spike was indeed genuine, it forces us to confront a staggering mystery. What natural process inside a cloud of ionized gas can concentrate such an immense amount of energy and release it in a single, fleeting instant? Imagine the entire power of a star, focused and unleashed in a flash shorter than a human heartbeat. Our current models of plasma physics have no mechanism for such an extreme, localized detonation. It suggests the existence of a previously unknown trigger, a cosmic switch that can tap into reservoirs of energy we can scarcely comprehend. Was this the death cry of a microscopic region within the nebula, a magnetic short circuit on an astronomical scale? Or did we intercept a fragment of something far larger, a piece of a message or a weapon so powerful we mistook its signature for a natural event? The Lagoon Nebula, a place of birth for new stars, may also be the site of cosmic violence on a scale we are only beginning to witness. The explosive power of the Lagoon Nebula spike gives way to an entirely different kind of mystery, one of intricate and unnerving design. From the tri-lobed beauty of the Trifid Nebula, a 10th signal arrives not as a blast of energy but as a complex tapestry woven into time itself. When astronomers plotted its intensity over thousands of hours, they did not see a random scatter of points. Instead, a breathtaking image emerged, a graph of rising and falling power that was perfectly symmetrical. The pattern mirrored itself along a central axis, a graceful, swooping curve on one side reflected with mathematical precision on the other. It was not just a simple reflection either. As researchers zoomed in on smaller sections of the signal, they found the same symmetrical motif repeating at smaller scales, a hint of a fractal-like structure embedded within the cosmic noise. This is the kind of order we simply do not expect from a cloud of superheated, chaotic gas. Natural processes tend to be messy, their outputs lopsided and unpredictable. Think of a lightning strike. Its path is jagged and unique, never a perfect mirror image. So what could possibly create such flawless symmetry in the heart of a nebula? One compelling line of inquiry points toward the plasma itself. Under specific and extreme conditions, magnetized plasma can theoretically form self-organizing structures. Vast swirling vortices or standing waves could develop within the cloud, and if their interactions are balanced just right, they might produce an emission pattern that appears symmetrical to our instruments. It would be like watching the intricate, symmetrical patterns that form in a spinning vat of oil, but on a cosmic scale. Yet, the fractal-like quality pushes this idea to its limit. It suggests a level of complex, recursive organization that feels almost algorithmic, as if a set of simple rules is being executed over and over, building the signal from the ground up. This leads to a far more speculative and profound question. Could we be looking at a signature not just of self-organization, but of something that resembles a natural computation? Is the Trifid Nebula, in its chaotic dance of energy and matter, accidentally performing a kind of cosmic mathematics, its output resembling a code we instinctively recognize? Or does this perfect symmetry point to a different kind of source altogether, one that imprints order with deliberate intent? The signal from the Trifid Nebula blurs the line between a natural phenomenon and a crafted message, leaving us to wonder if we are studying physics or deciphering a cosmic signature. The flawless symmetry of the Trifid Nebula is replaced by a source of pure, unpredictable fury. Deep within the stellar forge of the Eagle Nebula, the 11th signal erupts without warning or pattern. Astronomers call it the intermittent burster, a source that unleashes short, devastatingly powerful radio bursts at completely irregular intervals. One moment, the silence is absolute. The next, a spike of energy tears through the void, only to vanish as quickly as it appeared. Days, weeks, or even months may pass before it fires again, offering no rhythm, no cycle, and no clue as to what triggers its violent outburst. This capricious nature makes it one of the most frustrating and elusive objects to study in the entire cosmos. How can you understand a phenomenon that refuses to follow any rules? The primary challenge is one of simple observation. Our telescopes cannot stare at a single patch of sky indefinitely, and with no predictable schedule, we are left to catch the burster by pure luck. It is like trying to study a specific lightning bolt in a thunderstorm. You know another will strike, but you have no idea where or when. This randomness forces scientists to rely on statistical models and chance detections, piecing together its behavior from fragmented, incomplete data. The leading theories attempt to explain this volatility through the nebula's own turbulent heart. One idea points to variable stellar winds. Imagine a newborn, hyperactive star within the cloud, its surface boiling with immense magnetic activity. This star might belch out vast waves of charged particles, its solar wind fluctuating wildly in intensity. When an especially dense clump of this wind slams into the surrounding nebula plasma, it could trigger a brief, powerful burst of radio emission. The irregularity would simply reflect the chaotic, stormy nature of the star's adolescence. Another compelling explanation involves magnetic reconnection. The Eagle Nebula is laced with immensely powerful and complex magnetic fields. These fields can become twisted and strained, storing enormous energy like a coiled spring. When the tension becomes too great, the field lines snap and violently reconfigure themselves, a process known as reconnection. In an instant, all that pent-up magnetic energy is released, accelerating particles to near-light speeds and creating a brilliant flash of radio waves. The intermittent nature of the bursts could then be due to the build-up and release of this magnetic stress at random points throughout the cloud. Yet, even these explanations feel incomplete. The sheer power of the bursts, combined with their total lack of a schedule, pushes at the edge of our plasma physics. It suggests a system operating at a threshold of instability, perpetually on the brink of eruption. Is the intermittent burster merely a natural safety valve for a cosmic pressure cooker, or are we witnessing the faint, unpredictable signature of a much deeper and more volatile process at work within the pillars of creation? The chaotic fury of the intermittent burster is replaced by a symphony of cosmic cooperation. From the brilliant stellar factory of the Omega Nebula, a 12th signal arrives not as a single note but as a multi-wavelength chorus. This phenomenon was detected not just by radio telescopes, but simultaneously by instruments tuned to infrared and even faint X-ray frequencies. It was a single, unified event singing across the entire electromagnetic spectrum, a coordinated performance that suggests a source of immense and interconnected energy. Imagine hearing a thunderclap while simultaneously seeing the lightning flash and feeling the rumble in your chest. This signal is the cosmic equivalent, a single cause producing a cascade of effects we can detect in different ways. This coordinated emission immediately rules out many simple explanations. A random plasma instability might produce a burst of radio waves, but it would not necessarily light up in infrared and X-rays at the exact same moment. This points toward a much more substantial and complex event, one that involves multiple physical processes working in concert. The most plausible scenario involves the violent birth of stars. Deep within the Omega Nebula, a dense core of gas and dust could be collapsing to form a new protostar. As it spins and accumulates mass, it can launch powerful jets of material which slam into the surrounding nebula at nearly the speed of light. The impact itself would generate intense heat glowing brightly in the infrared. The shock waves from this collision would accelerate particles to enormous energies, creating the radio emission. And if the jets are powerful enough, the most energetic particles within them could be responsible for the faint, high-energy X-ray signature. It is a single cosmic engine with different parts producing different wavelengths of light. Yet, the sheer coordination and intensity of this chorus push at the boundaries of even this dramatic model. It suggests a level of efficiency and power in these stellar birth processes that we have rarely witnessed. Could there be an unknown high-energy process at work, something that more effectively couples the different layers of the nebula's energy output? Is this multi-wavelength signal the standard song of a star being born? Or are we hearing a special performance, one where the conditions were just right for the universe to reveal the profound connections between its most fundamental forces? The multi-wavelength chorus from the Omega Nebula is a symphony of cosmic light, but our 13th signal offers a mystery of profound silence. Within the sprawling emission of the IC 1396 Nebula, a complex tapestry of radio noise crackles and pops with the expected energy of a vibrant stellar nursery. Yet, buried within that cacophony is a void. One specific frequency band is utterly, impossibly silent. It is not a faint whisper or a weak signal, but a total absence, a clean slice cut out of the spectrum as if by a cosmic scalpel. This is the silent gap anomaly, a hole in the sound of the universe. The most straightforward scientific explanation is absorption. We see this principle at work in our own atmosphere, where certain gases absorb specific colors of sunlight, leaving dark lines in the spectrum. In IC 1396, this gap could mean that an unknown cloud of cold gas and dust lies between us and the nebula's bright core. As the nebula's broad emission tries to pass through this cloud, the cloud's unique chemical composition would absorb one very specific frequency, swallowing it whole and creating the silent gap we detect. The problem is, when astronomers search for the telltale signs of this absorbing material, they find nothing. No known molecule, no common element, and no exotic dust grain corresponds to this exact frequency. It is a fingerprint that does not match any suspect in our cosmic database. This leads to a more speculative line of thought. Could this be a form of natural cosmic censorship? Perhaps the conditions within the nebula itself are so extreme that they create a self-masking effect, where a powerful local magnetic field or a shell of dense plasma actively suppresses emissions at that one frequency, creating a quiet zone in the radio spectrum. Or consider a more unsettling possibility. What if the silence is not a natural filter, but a deliberate act? If an intelligence were broadcasting within the nebula, the most efficient way to hide a signal is not to encrypt it, but to bury it in a gap of silence, a place where no one would think to look because nature abhors such a perfect vacuum of information. Is the silent gap anomaly simply a shadow cast by a material we have yet to discover? Or is it a curtain drawn shut to hide something we are not meant to hear? The silent gap leaves us listening for an absence, but our 14th signal demands attention with its frantic, vibrating energy. In the sprawling, continent-shaped clouds of the North America Nebula, a source flickers with an almost impossible speed. This is the rapidly oscillating source, a beacon that pulses not with the stately rhythm of a pulsar, but with a frenetic, high-frequency tremor. Its oscillations are so rapid they push the very limits of what our instruments can resolve, a strobe light flashing in the cosmic dark faster than the beat of a hummingbird's wings. To produce such a rapid modulation within a plasma environment requires physics operating at the extreme. Think of trying to make a vast ocean wave vibrate as quickly as a guitar string. The inertia of all that water fights against such rapid movement. The plasma in a nebula is similar, a massive, diffuse medium that resists quick changes. So what cosmic engine could possibly be shaking it so fast? One compelling theory points toward a tiny, incredibly dense object. A white dwarf or neutron star spinning at a staggering rate could be the culprit. As it rotates, its magnetic field whips through the surrounding plasma, acting like a dazzlingly fast lighthouse beam. But to achieve these specific oscillations, the spin would need to be phenomenally rapid, challenging even our models for these extreme stellar remnants. Another possibility lies not in a solid object but in the plasma itself. Perhaps we are witnessing a powerful plasma instability, a natural vibration within the cloud's own magnetic fields. Under the right conditions, these fields can enter a state of intense, resonant vibration like a plucked string, releasing energy in a rapid, oscillating burst. The frequency of this vibration is dictated by the plasma's density and the magnetic field's strength, and in the heart of the North American Nebula, these conditions might just be perfect for creating this ultra-fast tremolo. Yet the sheer speed of the oscillation remains deeply puzzling. It suggests a system of immense energy and precision, a natural metronome set to a tempo we scarcely knew the universe could keep. Is this the signature of a dying star's final, frantic spin, or are we seeing a new form of plasma wave, a fundamental vibration of a magnetic field on a scale we have never before observed? The rapidly oscillating source does not just pulse, it questions our understanding of how fast the cosmos can truly move. The frantic oscillations of the North American Nebula fade into a whisper, replaced by a signal of profound and subtle connection. From the delicate, wispy tendrils of the Cocoon Nebula, a faint, almost ghostly radio pulse was detected. On its own, this whisper-thin signal would have been dismissed as background static, but its timing was everything. It arrived within a fraction of a second of a gravitational wave event recorded by observatories here on Earth, a ripple in space-time caused by the collision of two distant black holes. This correlation was not a one-time coincidence. On multiple occasions, as gravitational waves from various cosmic cataclysms washed through our region of the galaxy, the Cocoon Nebula seemed to respond with its own faint, corresponding electromagnetic sigh. This has led to a breathtaking and deeply controversial idea known as the gravity echo hypothesis. The theory suggests that the vast cloud of plasma in the Cocoon Nebula is not merely a passive bystander to these events. Instead, it may be acting as a natural transducer, a cosmic instrument that converts one form of energy into another. As the invisible ripples of gravity pass through the cloud, they could be subtly squeezing and stretching the ionized gas within. This minute distortion, this vibration imparted by spacetime itself, might then excite the plasma, causing it to emit the faint radio waves we can actually detect. It is the universe's most elegant feedback loop, where the bending of space itself creates a whisper we can finally hear. The implications of this are staggering. If proven true, it would give us an entirely new way to observe the cosmos. Gravitational wave astronomy is in its infancy, like having a new sense that allows us to feel the vibrations of the universe. But if plasma clouds can act as transducers, then every nebula, every wisp of interstellar gas could become a potential loudspeaker for gravity. We could, in theory, map the gravitational wave background of the universe by listening to the chorus of whispers from clouds like the Cocoon. We could hear the echoes of black hole mergers that are otherwise invisible to us, their stories told not by light, but by the way they make the very fabric of space sing through the medium of plasma. Yet the hypothesis remains on the razor's edge of acceptance. The correlation is tantalizing, but the signal is so faint that skeptics argue it could still be statistical noise, a persistent cosmic mirage. The true test will be in the next major gravitational wave event. Will the Cocoon Nebula and others like it sing in unison once more? If they do, we may be witnessing the birth of an entirely new field of astronomy, one where we listen to the silent music of gravity as it plays upon the strings of interstellar plasma. The whispers of the Cocoon Nebula fade into a far deeper past. Our 16th signal emerges from the heart of the Soul Nebula, not as a complex pattern or a powerful burst, but as a ghost from the dawn of time. Its significance lies not in what it says, but in what it is made of. When astronomers split its light into a rainbow of colors, they found its spectral lines were a perfect match for a chemical composition that is almost impossibly pure. It contains only hydrogen and helium, the two primordial elements forged in the first few minutes after the Big Bang, with no detectable traces of the heavier elements like carbon, oxygen, or iron that are forged inside stars and scattered by their explosions. This signal is a relic, a pristine sample of the early universe's raw material, preserved in transit and now being broadcast to us by the Sol Nebula's plasma. Think of it like finding a perfectly preserved fossil frozen in ice, its DNA untouched by millions of years of evolution. This signal has traveled for eons through the vast, empty reaches of intergalactic space before finally entering the turbulent plasma of the Sol Nebula. The fact that it has passed through that cloud and reached us with its primordial signature intact is a miracle in itself. Normally, a journey through such a turbulent, ionized environment would scramble the signal's properties, contaminating it with the nebula's own complex chemistry. The fact that it did not means this ancient light must have passed through a rare, quiet corridor within the cloud, a region of such serene stability that it acted as a perfect cosmic conduit. This presents a breathtaking possibility. We may be looking at a direct window into the conditions of the infant universe, a time before the first stars had even ignited, when the cosmos was a dark, simple sea of hydrogen and helium. The plasma of the Sol Nebula is not generating this signal. It is merely illuminating it like a spotlight falling upon an ancient traveler who has been walking in the dark for billions of years. What secrets does this ancient light carry within its simple, elemental structure? Could its subtle fluctuations tell us about the density of matter in the universe's first billion years, or the texture of the cosmic microwave background when it was still young and hot? This is more than just a signal. It is a message in a bottle from creation itself, and its very existence challenges our understanding of how information can survive the violent journey across cosmic time. This cosmic whisper from the dawn of time is followed by a signal that actively argues with the universe. Within the petal-like structure of the Rosette Nebula, the 17th signal presents a baffling anti-correlation mystery. Its behavior is not just isolated, it is reactive. When a powerful gamma ray burst or a distant supernova flash occurs in its general vicinity, this specific radio signal does not intensify or echo the event. Instead, it does the exact opposite. Its strength noticeably and reliably drops. It is as if the nebula is flinching, turning down its own volume in response to a cosmic shout. This is more than just a coincidence. The anti-correlation has been observed multiple times, creating a statistical relationship that is impossible to ignore. Why would a cloud of plasma grow quieter when bathed in a wave of external energy? One compelling theory involves vast, interconnected magnetic fields. Imagine the Rosette Nebula is not an island, but part of a larger, invisible network of magnetic force that stretches across light years. When a gamma-ray blast ripples through this network, it could temporarily reconfigure the field lines within the rosette itself. This magnetic shuffling might disrupt the specific conditions that generate the radio signal, effectively silencing its source for a short time. It would be like a power surge causing the lights to flicker in a distant city because they are on the same fragile grid. Another, even more profound, idea casts the plasma cloud in the role of a cosmic buffer or a shield. The nebula's immense, diffuse body could be absorbing the incoming high-energy radiation, using its own substance to dissipate the blast. In doing so, the energy that would normally go into producing the radio signal is instead diverted to this protective function, causing the observed dip. The nebula is sacrificing its own voice to dampen a shock wave. This paints a picture of the interstellar medium not as a passive backdrop, but as an active, dynamic participant in cosmic events, one that can absorb and respond to the universe's most violent outbursts. Is the Rosette Nebula simply a victim of magnetic interference, or is it a guardian, using its own body to shield whatever lies behind it from the fury of a gamma-ray burst? This anti-correlation is a conversation, a faint argument in the dark that reveals just how deeply connected the cosmos truly is. The universe's reactive conversation gives way to a rhythm that feels almost alive. From the crimson glow of the California Nebula, a signal pulses with the steady, reassuring cadence of a heartbeat. Its primary rhythm is metronomic, a reliable thump of radio energy that ticks away with the constancy of a living organ. But it is the anomaly within this rhythm that truly captivates the mind. Every so often the pattern stutters. The signal skips a single, expected beat, leaving a moment of silence before it resumes its regular pulse as if nothing had happened. This transient heartbeat, with its occasional and unpredictable flutters, is a masterclass in cosmic pattern recognition. Our brains are hardwired to find familiar shapes in randomness, to see faces in clouds and creatures in the stars. This signal taps directly into that instinct. It feels biological, not because it is, but because its rhythm mirrors one of the most fundamental patterns we know, the beat of a heart. Scientists are quick to point out the almost certain coincidence. The complex magnetohydrodynamics of a vast plasma cloud can easily produce resonant oscillations that appear periodic. The occasional skip could be the result of a localized magnetic reconnection event, a small hiccup in the nebula's immense magnetic field that briefly disrupts the emission mechanism before it restabilizes. It is like a vast cosmic drum whose skin is occasionally tapped by an outside force, causing it to miss a single stroke in its otherwise perfect rhythm. Yet, knowing the physics does little to quiet the imagination. This signal forces us to confront the very limits of our interpretation. When we look at the cosmos, are we truly seeing what is there, or are we merely projecting our own experiences onto the void? The California Nebula's heartbeat is a Rorschach test painted across light years, a pattern that is scientifically explicable but emotionally resonant. It asks us where the line falls between cold, hard data and the profound human need to find meaning in the dark. The universe has a periodic table of its own, but from the ghostly visage of the Witch Head Nebula, a signal arrives that defies it. This 19th mystery is the spectral line anomaly, a fingerprint of light that simply does not belong. When astronomers disperse its radio waves into a spectrum, they find sharp, dark lines etched into the data at specific frequencies. These are the calling cards of atoms and molecules, each one absorbing a unique color of light and revealing the chemical makeup of the source. But the lines from the Witch Head do not correspond to hydrogen, oxygen, or carbon. They do not match any of the complex molecular chains of interstellar dust. They are alien, a set of spectral signatures that our entire catalog of cosmic chemistry cannot identify. It is like finding a set of unfamiliar fingerprints at a crime scene belonging to no one in any database on Earth. The immediate, thrilling possibility is that we have found evidence of exotic matter. This could be a form of plasma existing under such extreme conditions of temperature and pressure that its atoms behave in radically new ways, emitting and absorbing light at frequencies we have never before recorded. Or it might hint at the existence of stable, super-heavy elements that cannot be forged in any star we understand. Elements from the island of stability predicted by theoretical physics but never before observed in nature. Yet another possibility is more subtle but no less profound. The anomaly may not be a new substance but a new process. Perhaps the turbulent magnetic fields within the Witch Head are so powerful that they are twisting the quantum states of ordinary atoms, forcing them to produce these strange spectral lines under duress. This would be like hearing a familiar musical instrument play a note you never knew it could produce because it was being played inside a hurricane. The very laws of physics, as we have written them, may be incomplete, unable to describe how light and matter interact in the most chaotic corners of the cosmos. Is the Witch Head Nebula hiding a pocket of the universe built from different stuff? Or is it simply showing us that our understanding of the ordinary stuff is far from complete? This spectral ghost challenges the foundation of spectroscopy itself, the very tool we use to read the story of the stars. Two separate points of light within the flame nebula began to speak to one another. Designated the coordinated double source, these two distinct radio emissions originated from locations separated by trillions of miles, a distance so vast that light itself would take weeks to travel between them. Yet their transmissions were perfectly synchronized, pulsing in flawless unison as if controlled by the same cosmic conductor. This was not a mere coincidence of timing. The two signals rose and fell together, their intricate modulation patterns locked in step across the unimaginable gulf. How could two independent regions of a turbulent plasma cloud possibly achieve such perfect harmony? The most straightforward explanation points to a single, powerful energizing source hidden deep within the nebula. Imagine a brilliant lighthouse whose single, rotating beam sweeps across two distant buoys, making them flash at the exact same instant from our perspective. A colossal protostar or a hidden black hole could be flooding the entire region with a periodic wave of energy, exciting both plasma clouds simultaneously and forcing them to broadcast the same rhythm. Yet this theory faces a challenge. The signals are not simple pulses, they are complex waveforms. For a single central source to imprint such intricate, identical patterns on two separate and turbulent clouds, the energy would have to propagate and be translated with flawless fidelity, a level of coordination that seems physically precarious over such distances. This leads to a second, more exotic possibility, that the plasma structures themselves are intrinsically interconnected. The flame nebula might be threaded by a powerful, coherent magnetic field, a rigid cosmic architecture that acts like a taut wire connecting the two sources. A disturbance at one point would vibrate along this magnetic backbone instantly, triggering an identical emission at the other end. The entire system would act as a single, resonating instrument. This suggests a level of large-scale organization within nebulae that we are only beginning to suspect, but the flawless synchronization pushes some minds toward a final, staggering thought. Could this be a form of coordinated activity? Is it possible that what we are witnessing is not a single natural event, but two separate events operating from a shared, prearranged schedule, like two distant radios tuned to the same precise time signal? The coordinated double source forces us to ask if the universe possesses a deeper, hidden connectivity, one where separate points can act as one across the void. Deep within the vibrant chaos of the running chicken nebula, a signal defies one of the most fundamental rules of thermodynamics. This 21st signal presents the energy inversion paradox, a phenomenon where the expected distribution of energy is completely flipped on its head. In any normal, hot object, from a simple light bulb filament to the surface of a star, energy is concentrated at lower frequencies. Think of a bar of iron heating in a forge. It first glows a dull red, the lowest energy form of visible light. As it gets hotter, it moves up the spectrum to orange, then yellow, and finally a brilliant white blue. The energy always tapers off at the highest frequencies. But the signal from the running chicken nebula does the exact opposite. Here, the radio waves are far more intense and energetic at the very highest frequencies, while the lower frequencies are surprisingly weak. It is as if that iron bar was glowing with intense ultraviolet light while remaining cool to the touch, a physical impossibility according to our standard models. This is not merely an oddity, it is a direct challenge to our understanding of how energy behaves within a plasma. Something inside that cloud is not just heating the gas, it is selectively and violently accelerating particles in a way that preferentially creates high-energy emissions. One potential explanation lies in the realm of plasma waves. Under specific conditions, powerful waves rippling through the magnetized plasma could act like a vast natural particle accelerator. These waves can transfer energy to electrons, whipping them to velocities close to the speed of light. When these ultra-relativistic electrons are then forced to spiral along magnetic field lines, they emit synchrotron radiation, a type of emission that can indeed be skewed toward higher frequencies. But for the inversion to be this pronounced, the acceleration process would have to be phenomenally efficient and localized, a cosmic version of a perfectly tuned machine gun firing particles to extreme energies. This paradox forces a question with profound implications. Is the running chicken nebula hiding a natural particle accelerator of unimaginable power, one that operates on principles we have yet to discover? Or does this inverted signal point to a completely new form of energy transfer, a process where the chaotic turbulence of the plasma does not dissipate energy, but focuses it into a coherent, high-frequency scream against the cosmic silence? This energy inversion paradox is not just a cosmic curiosity. It is a direct challenge to our textbooks, and solving it requires us to venture into some of the most extreme physics known to exist. The primary suspect in this case is a phenomenon known as nonlinear plasma waves. Imagine the nebula's magnetic field not as a static scaffold, but as a vast, turbulent ocean. Under the right conditions, immense waves can form on this magnetic sea, growing steeper and more powerful until they break, just like a tidal wave crashing onto a shore. When these nonlinear waves break, they can create incredibly sharp, intense electric fields. These fields act like natural slingshots, violently accelerating stray electrons to nearly the speed of light. These ultra-energetic electrons then radiate their energy away, but they do so preferentially at the highest frequencies, creating the intense high-energy radio signal we observe. It is a compelling idea, but the evidence is circumstantial. We have seen such waves in laboratory plasmas and in the sun's corona, but to have them operate on a scale large enough and with enough power to illuminate an entire nebula in this inverted way would be unprecedented. A second, equally powerful theory involves a process called inverse Compton scattering. Here, the culprit is not magnetic waves but light itself. The nebula is flooded with low-energy photons, the faint starlight from all its newborn suns. The theory proposes that a population of already high-energy electrons is zipping through this cloud. When these fast-moving electrons collide with the gentle, low-energy starlight, they effectively kick the photons, transferring a huge amount of their own energy to them. It is like a professional baseball player hitting a slow-pitch softball, sending it flying out of the park with incredible force. In this cosmic game, the gentle starlight is transformed into the high-energy radio waves we detect. The evidence for this is strong in other contexts, like quasars, but to see it so dominantly in a stellar nursery is unusual. It requires a perfect and seemingly unnatural balance between the number of high-energy electrons and the density of starlight. This very need for perfection leads to the most dramatic explanation of all, that the running chicken nebula is hiding a built-in particle accelerator. This would not be a machine built by intelligence, but a natural one, perhaps powered by a rapidly spinning neutron star or the intense shock waves from a recent supernova. Such an object could act as a relentless engine, funneling and focusing chaotic plasma energy into a coherent beam of high-energy particles, a process far more efficient and targeted than the diffuse turbulence of nonlinear waves. The main evidence against this is simple. We have not yet found the accelerator itself. It remains hidden within the nebula's glowing folds, so we are left with a choice between a storm of magnetic waves, a cosmic game of energy transfer, or a hidden natural machine. Each theory pushes the boundaries of known physics, forcing us to wonder if the paradox is not a flaw in our observation, but a glimpse into a more violent and ordered universe than we ever suspected. Some signals defy our attempts to categorize them entirely. From the sprawling wings of the Cygnus Nebula, a 20-second signal was catalogued, studied, and then, without any warning, it simply ceased to exist. For years, our most powerful radio dishes were trained on that patch of sky, listening for its return, but they heard only the ordinary hiss of the cosmos. The signal was declared lost, a transient ghost that had faded back into the void. Then, decades later, it was back. New observations captured it with absolute clarity, and the data was undeniable. This was not a similar signal, it was the same one, possessing an identical and highly complex waveform, the same frequency modulation, the same spectral signature. It had returned as if it had never left, picking up its cosmic broadcast right where it had left off. This vanishing act forces astronomers to confront a baffling set of possibilities. The first is a long-term cyclical event. Could the source be an object on an immensely long and eccentric orbit, one that only swings into a position where its transmissions are aimed at Earth once every few decades? Think of a distant, icy body in our own solar system that only becomes active when it nears the Sun, but on a scale spanning centuries. Another explanation is an intermittent source with an incredibly slow duty cycle. Perhaps the engine powering this signal builds up energy over a period of many years, reaches a critical threshold, broadcasts until its energy is depleted, and then shuts down to recharge. It would be a cosmic geyser with an eruption schedule we are only now beginning to map. The most intriguing and unsettling idea is that the source itself is moving. It may not be fixed within the Cygnus Nebula's plasma, but could be an independent object passing through the cloud. For a time, its path was clear and we could hear it. Then it drifted behind a dense wall of obscuring gas and dust within the nebula, silencing it for years until its journey brought it back into our line of sight. This raises a profound question. What kind of object can move through a turbulent plasma cloud while maintaining the stability to produce a signal of such perfect consistency? Is it a rogue planet with a phenomenally powerful magnetosphere, or something else? Something that navigates the interstellar depths and uses the nebula not as a home but as a temporary harbor? The signal that returned reminds us that the cosmos operates on timescales far beyond our own, and that a silence from the stars may only be a pause in an infinite conversation. A ghost of a wave ripples through the Lagoon Nebula, but this signal is no solitary traveler. It arrives as a series of bright and dark bands, a textbook-perfect interference pattern etched into the radio static. This is the signature of a wave phenomenon, the same kind of pattern you see when you throw two stones into a still pond. The ripples from each stone spread out, and where a peak from one meets a trough from the other, they cancel each other out, creating a line of stillness. Where peak meets peak, they amplify, creating a band of heightened intensity. The fact that we see this pattern in a signal from deep space means that somehow this radio emission is behaving like a coherent wave with multiple parts of it interfering with itself. The most direct earthly analogy is the famous double-slit experiment, a cornerstone of quantum mechanics where a single particle seems to pass through two slits at once and interfere with its own potential path. While we are not dealing with quantum particles here, the principle is eerily similar for classical waves. It suggests that this signal did not originate from a single, chaotic point of turbulence. Instead, it must have emanated from at least two distinct, coordinated sources, or passed through a structured filter that split it into separate, coherent wavefronts before they merged again on their journey to Earth. How could such a thing occur naturally within a seething cloud of plasma? One possibility is that the signal is being generated by two closely spaced, oscillating regions within the nebula, their emissions perfectly synchronized so that their waves march in lockstep across the light years. Another, more profound idea is that the signal passed through a natural diffraction grating, perhaps a vast, regular lattice of dense plasma filaments or an intensely ordered magnetic field within the cloud. This structure would act like a cosmic version of the slits, splitting the wave and forcing it to interfere with itself. The very existence of this clean, wave-like pattern challenges the assumption that plasma emissions are inherently messy and disordered. It implies a source or a pathway of astonishing coherence, a pocket of the universe where chaos gives way to a brief, perfect order. Are we seeing the signature of a natural, resonant cavity within the nebula, a place where waves are shaped and sculpted? Or does this precise interference point toward a source that is not merely natural but structured, engineered to produce this very effect as a way of announcing its presence not with a shout, but with a whisper of pure physics? That precise interference pattern fades into a far more diffuse and ghostly presence, our 24th signal. This is not a sharp burst or a clear tone, but a faint, pervasive radio whisper that seems to soak the spaces between the stars. For years, it was dismissed as an unremarkable component of the cosmic background static, an uninteresting hiss that was filtered out in the search for more dramatic signals. Its true nature was only uncovered by accident when a research team cross-referenced its faint, shimmering map with a completely different kind of chart, a map of the universe's hidden skeleton. This signal shows a startling statistical correlation with the inferred distribution of dark matter. In regions of space where gravitational lensing and galactic rotation curves suggest vast halos of dark matter are concentrated, this faint radio signal is subtly but consistently brighter. It is as if the invisible mass of the universe is casting a faint electromagnetic shadow. This correlation has ignited one of the most speculative and exciting theories in modern astrophysics, the possibility that we are detecting an indirect emission caused by dark matter itself. The prevailing view is that dark matter is inert, only interacting with the normal matter of stars and plasma through gravity. It passes through our world and through us as if it were a ghost. But what if that is not entirely true? What if certain theoretical particles that make up dark matter, such as actions or sterile neutrinos, can on very rare occasions interact with the intense magnetic fields within plasma clouds? In such a rarefied event, the theory suggests a dark matter particle could convert into a low-energy photon, a single quantum of radio light. Individually, these events would be undetectable. But across the immense, galaxy-spanning reservoirs of dark matter, these rare interactions could collectively produce the very faint, pervasive glow we are now mapping. The plasma clouds in this scenario are not the source of the signal, but the catalyst, their powerful magnetic fields providing the stage for this ghostly transformation. This would mean that the dark, silent majority of the universe's mass is not completely silent after all. We may have been listening to its whisper for decades without realizing it, a whisper that only becomes audible when it sings in a duet with the magnetized plasma of the visible cosmos. If this theory holds, it would be a breakthrough of unimaginable proportions, finally giving us a way to perceive the invisible architecture that holds the universe together. We would no longer be mapping dark matter by its gravitational shadow alone, but by its own faint voice, a voice that has been humming in the background all along. This final signal stands apart from all others, not for its power or its pattern, but for the sheer elegance of its message. From the quiet expanse of a seemingly ordinary plasma cloud, a transmission was received that mimicked a fundamental truth of mathematics itself. Its frequency ratio was not a random value, but an astonishingly precise approximation of pi, the constant that defines the ratio of a circle's circumference to its diameter. It was the universe seemingly whispering a number we discovered with chalk on a slate, a cornerstone of geometry echoing back to us from the void. This discovery ignited a firestorm of debate that cuts to the very heart of our search for meaning in the cosmos. On one side are the researchers who see this as a profound clue to a deeper cosmic order. They argue that pi is a transcendental number. It appears in the physics of waves, the structure of spacetime, and the equations governing all rotating systems. For a natural process to generate a signal so cleanly aligned with pi, it would suggest that our mathematics is not just a human invention, but a native language of the universe. This signal, they propose, could be a universal beacon, a kind of cosmic primer built from a constant so fundamental that any technological civilization would inevitably recognize it. It would be the most efficient way to announce, "We are here, and we understand the same rules that you do." The other side of the debate urges extreme caution, warning of a powerful cognitive trap known as apophenia, the human tendency to perceive meaningful patterns in random noise. They point out that with trillions of potential signals coursing through the galaxy, it is statistically almost inevitable that one of them, by pure chance, will closely resemble a significant number. Our brains are pattern recognition engines hardwired to find faces in clouds and messages in static. To these skeptics, the pi signal is the ultimate cosmic Rorschach test, a Rorschach test where we are desperate to see a fingerprint of intelligence. They demonstrate through complex computer simulations that turbulent plasma, under certain rare and specific conditions of magnetic confinement and harmonic resonance, can indeed produce oscillations whose ratios briefly lock onto values very close to simple constants. The pi signal, in this view, is not a message but a mirage, a fleeting and beautiful coincidence born from the chaotic but mathematically governed dance of superheated gas. So where does that leave us, caught between the dizzying possibility of contact and the sobering reality of statistics? This ultimate enigma forces a question far more personal than any other. It asks us to look inward and question the reliability of our own hope. Are we witnessing the first gentle knock on the door of a universe teeming with mind? Or are we merely hearing the cosmos hum a tune we mistakenly believe was written just for us? The silence that follows this signal is not empty, it is filled with the weight of our own interpretation. 25 signals, each a unique and stubborn riddle, stand as monuments to our cosmic ignorance. From the gentle breathing of the whispering giant to the mathematical perfection of the pi signal, this collection reveals a universe far more complex and wondrous than we ever dreamed. These are not mere anomalies to be filed away, they are fundamental challenges to our understanding of plasma itself, the very substance that paints the nebulae and fills the space between the stars. Each one pushes at the boundaries of our physics, forcing us to rewrite the rules of how energy behaves, how order emerges from chaos, and how information might travel across the light years. They whisper of natural processes we have yet to discover, of cosmic instruments playing a symphony we are only beginning to hear. So the next time you find yourself looking up at a dark, star-filled sky, remember that the silence is an illusion. The void is humming with whispers, pulsing with heartbeats, and echoing with the ghosts of ancient light. The universe is not a quiet neighbor, it is a vibrant, talking cosmos, and we have only just learned how to listen. We want to know which of these 25 cosmic enigmas captured your imagination the most. Was it the coordinated dance of the double source, the patient silence of the returning signal, or the chilling possibility of the dark matter whisper? Tell us in the comments below and keep looking up. The greatest mysteries are still waiting for us just beyond the next cloud of interstellar dust.